So welcome to my talk, Large Language Models for Web Developers. My name is Roy. I'm a lifelong software developer, also startup founder in the past, currently working in product management. And for the past 2 years, I've been working on a few AI products. So in this talk, I want to show you some of the things, or the concepts mostly, I've been working on, how to use as a web developer or a software developer, or basically anyone that knows how to write code, interested in learning how to work with AI and large language models. And for this, it's good to understand what actually changed in the last 2 years. I think it was November 2022 or something when ChatGPT was released, and everyone was suddenly shocked about what AI can actually do. But if you think about what AI was like in 2016, so in 2016, the company I was working on at the time, we were building like a TV guide application. And for this TV guide application, we thought it would be nice if we have a recommendation engine that tells you based on whatever you watched in the past, we're going to recommend you to watch these and these shows that are running on these and these times. So 2016, people were still watching like general cable TV or digital TV, basically anything that wasn't Netflix. And I went to a university in the UK. So Cambridge over there, they have their own Cambridge. And I was doing a machine learning course for I think I was there for a week. And in a week I learned how to work with Python and Pandas and a few other libraries. If you work with Python, you probably recognize some of these names. And we were building a small model, like a locally running machine model, that was able to distinguish between blueberry muffins and Chihuahua dogs. So this was in 2016. If you would put this in a large language model today that is able to recognize vision, you could probably do the same without doing any coding and without training any model. But in order to train these models, you needed to know a few things. You needed to know how to use Python. You needed to know a little bit about mathematics because there were some things you needed to actually do in code. And then you needed to know about statistics, machine learning, and computer science. So you actually had to run a lot of stuff locally. You had to write quite a bit of code. You needed to know how regressions work in general. So all these things you needed to know in order to write this small machine learning model. And if you think about today, you just go to, well, basically any big tech company, you go to the website, you click on a button that says chat, and you're able to do all these things without doing any coding. And then, of course, you can build this still yourself. You can use TensorFlow if you want to run it in the browser. You can use Python and Pandas still if you're a Python developer. Or, which I'm going to show you today, if you're a web developer, you can use APIs and SDKs that are available online in order to do this all by yourself as well, but with way less code than you had to write in 2016, and also way less knowledge about all the concepts you see on the screen. So AI today is, as you can see, it's chat assistant. It's people using a chat assistant in the browser on their machine, because there's all sorts of chat assistants that allow you to run models locally on your machine without the need for any internet. So I was on a long flight a few weeks ago and I was actually using Meta's Llama 3.2 model right there on my machine in the plane without me needing any internet connection or paying for ChatGPT Pro or any of those kind of things. Or it is, and I use this a lot myself, it's developers writing code in their editor and then having a copilot or a code assistant running there as well that is helping them by predicting next tokens and showing them what their code could look like if they use the chat assistant or the code assistant. So code assistants to me are really useful for a couple of things. I mostly use it to generate mock data or generate new code. You can actually use it to optimize existing code or to debug your existing code. But I feel it's usually kind of hard because it needs a lot of context. Unless you're working on like a small startup project, you need to know a lot of you need to give the LLM a lot of context on your code to be actually useful and helping you debug or solve some of your problems. What does work well if you isolate parts of your code, use that with an LLM or a chat assistant or a code assistant and try to get improvements on that code or try to create next iterations of that code. So for generate mock data, I personally like this example where let's assume you're creating a multilingual application and you want to get some labels translated. If you would do this before the LLM Before LLMs were available, you needed to write this object yourself. You needed to create all the labels. You needed to translate the labels. You're probably using the internet for it, but 20 years ago, you might have been using an actual translation guide. Now with LLMs, you can just create a new line. You maybe say what sort of language you want, and then the LLM is going to generate all of this for you. Or it's going to generate a whole bunch of stuff for you without you even putting in the languages you need. So this is really useful. It saves you a lot of time. You maybe go from working on this for an hour to working on this for minutes. Or to write tests. And this is something I do a lot as well. I hate writing tests unless I'm doing some test-driven development, which I usually don't really do. So LLMs are a really cool way to write your code, have the LLM generate a test for it, and then you at least have some sort of test harness. It won't be perfect. It won't be solving all your edge cases, but it might get you started on writing those tests, which is usually the hardest part, getting started with anything. I think I introduced myself already, but feel free to look me up on social media in case you want to know more about what I do. I also wrote some books and I go to conferences quite often, so if you want to see some of those, feel free to Google me there. I'm personally a big fan of React whenever I'm writing JavaScript, so the examples I'll be showing you today are using React whenever there's a front end involved. Okay, so in my opinion, AI has really changed how we write code as developers, at least for me personally. Does anyone feel like AI changed the way they write code? Quite a few of you. That's good. It's good to see. But how many of you actually knows what's going on whenever you open a chat assistant or whenever you start writing or typing in your IDE and it starts to generate some code for you? So that's the sort of questions I want to answer today. So think about a standard situation where you have your question and you're looking at the LLM to provide you with an answer. Like in between, a lot of things can happen. There's a few patterns I want to discuss today. Of course, you can do prompting, where you have a prompt with some instructions and your question. You send it to the LLM to get an answer. There are things that we call retrieval augmented generation. So this is where you use a vector database to store data, and then you use the data stored in the vector database to enhance the knowledge of the large language model. And then the final pattern I want to show you is actually two patterns. So it's tool calling. This is where we use tools, which are either a bit of code running somewhere or APIs or databases, together with a large language model. And the large language model is going to look at your list of tools and it's going to retrieve the data from these tools in order to get some real-time context it needs in order to answer your question. And then we also look a little bit at agents. So agents are most of the times using tool calling or retrieval augmented generation as a tool to answer your questions. The difference is agents are a bit more autonomous. So you'll ask them a question, the agent will do some planning, some reflection, whereas with sort of traditional or plain tool calling, you're going to enforce all of this to the LLM. So what happens in the middle is still involving some computer science, it's still involving some knowledge of mathematics or statistics, depending on what you're doing. For RAG, for example, you need to know a little bit about vectors in order to get the best possible results. So all of the things in the middle are still kind of similar to what you needed to do in 2016. I'd say you don't really need mathematics or machine learning, but computer science and statistics are useful. But even if you're not a computer science grad, or maybe you didn't have statistics in your education, if you're a self-taught developer and you know how to write code, with all the tools there are today, you should probably be able to build whatever you want to build. So in my opinion, you don't have to be a data scientist anymore to build AI applications. You might have heard about the term prompt engineer. So this is like 2 years ago. I think today we like to call developers building AI solutions, we like to call them AI engineers. So an AI engineer is not a machine learning engineer, which is an engineer building models, but an AI engineer in my mind, and I think this is a term a lot of people sort of agree with, an AI engineer is a developer using AI to build solutions, whether that's solutions for yourself or for an end user or for a customer or for a company internally. Doesn't really matter. It's developers building solutions using AI. So AI engineers there's a great conference called the AI Engineer Conference. So I think last year was the first edition or the second. And it's actually showing you what you can do as an AI engineer. It's also part of a podcast, which is called the Latent Space Podcast. I would really recommend you to have a look at those podcasts if you want to learn more about building AI solutions as a developer. So these are really focused on developers building AI solutions rather than where most of the media today is discussing how data scientists can develop AI solutions. Yeah, sure, it's the Latent Space Podcast. Yeah. If I do a next iteration of these slides, I'm going to put it in. So we can do this as developers by using these foundation models. So these LLMs really helped us to build AI solutions, because before we had large language models, you were using really specific models that needed to be trained by someone for a very specific use case. So the movie recommendation model I mentioned in the beginning is specifically trained to recommend movies. If you would ask about books, it probably won't be able to help you. If you ask it about the best places to visit in a certain city, it wouldn't know how to do it because it isn't trained on the data. So foundation models or large language models really help everyone to build AI solutions. So typically, if you think about the stack for building AI solutions, you all start with a large language model. There are a couple of models out there which are pretty good. I should probably rename the Google one from Lambda to Gemini. But most of the bigger tech companies, they have their own model. There are some bigger startups that have models as well. So OpenAI has the GPT models, which are, I think, the most popular models today. I work at IBM. We have a large language model called Granite, which is working pretty well for really business-heavy use cases. So Google has Gemini, which is a large language model similar to GPT, and Llama for Meta is one of my favorite ones together with Claude when writing code. So you have all these large language models. There are a couple of ways to access these models. You can either run them locally in your machine and then get some sort of API on top of it. But typically you would use a LLM provider or a model provider to access these models. So there's a couple of model providers out there. OpenAI, for example, has their own APIs. Google has their own APIs. Anthropic has their own APIs. At IBM, we have something called watsonx, where you can run your own APIs, your own models, which could be open source models, which could be the IBM models. And then typically developers use something like LangChain to connect to these APIs. Most of the providers have SDKs available that will help you to integrate these in your applications. I personally prefer using LangChain because with LangChain you get an abstraction level on top of all the large language models. So the worry always is if you build on one model and then make updates and you no longer like the model, it's going to be quite hard to migrate away if you're building on top of the APIs of the model provider or the SDKs of the model provider directly. So LangChain is a nice way to get some abstraction on top of all the model providers. And it also works with locally running models, which is pretty cool. So you have large language models, then you need a way to access those models using APIs or SDKs. And then finally, you can start building your application, whether that's a front-end app or a back-end app, it doesn't really matter. So this is more or less the stack when you want to build any application that involves AI. I would really recommend to look at LangChain, but if your company maybe has decided on a model provider, you can also look at their SDKs directly because, well, if you have to use them anyways, then why not use your own SDK? So with this stack, every developer is able to build their applications because they can get APIs and SDKs. And if you're a developer, you probably know how to use APIs and SDKs. So there are multiple patterns. As I mentioned in the beginning, we have basic prompting where you just do something we call LLM inferencing. So you're sending a prompt to the LLM and you're going to get an answer back. We have retrieval augmented generation where there's a vector database involved. And then we have tool calling and agents where you pass your own APIs and databases to the large language model. So let's start with prompt engineering. By now, I expect most people are doing some prompt engineering. They are writing prompts and hoping to get better results. So in short, a prompt is a natural language text describing the task you want the LLM to perform. And this task could be answering a question, this task could be giving recommendations, this task could be completing a sentence. Because what LLMs do is they predict the next bit of your question. And then prompt engineering is the process of creating better prompts, of playing with the prompt by using different patterns. So within prompting, there are different patterns you can use. I'm going to be showing you some of the patterns. But most of all, I think the models today are getting better, so the prompts are getting less important. And the context you give is the most important thing today, rather than how you would phrase your question. So 2 years ago, it was really important to write good prompts. I think today it's gotten less important because the models just got a little bit better. So the LLM inferencing or prompt engineering would look like this. You have your question. Your question will be put in a prompt. The prompt also has some instructions for the LLM, like be polite, be helpful, or give long answers or short answers. You send this to the LLM, and the LLM is going to give you the answer you want to see. So an example could be take the role of a personal travel assistant and answer the following question in detail. So let's look at some code for this. Here in Chrome, I have a small app running. So I built a small GPT clone, and I've put this in a repo, which I'll share with you as well. And in here, I can ask questions. So these are just LLM inferencing. So whatever I put in here will be sent directly to a large language model, and then the answer will be printed on the screen. So I can ask things like, what are the best places to visit in Atlanta? So this should go to the LLM, and then it should give you some instructions. As you can see, it's giving me part of the instructions I need. It's not giving me a complete string back because I'm using LangChain here, and I can actually tell LangChain how many tokens I would want to receive back. So when you interact with the large language models, you interact with them via APIs or SDKs. Whatever they return is an answer, and the answer consists of tokens. So it consists of words, but the words are tokenized, and there's actually limits you can set, because typically the LLM providers will charge you by token count. So the more tokens, the more expensive the response is going to be. So if we would go to our code, I should probably set the token count to be a bit higher, and then I should be able to get the result that I want to get. So if we ask again, refresh, so what are the best places to visit in Atlanta? Then now I should get a longer answer because it's no longer looking at the token count. Apparently it does, so probably I need to start doing some prompt engineering. So let me show you what the code looks like. There isn't much code involved. So the only code I actually have to interact with the model is in this file. So let's say it is 35 lines of code. So typically you start by importing the model connection. So in here I'm using IBM's watsonx. I can also use OpenAI, or I can use Anthropic, I can use Amazon Bedrock, I can use Google Gemini. There's like a whole range of connections you can use. You then import some core modules to write a prompt. So this is in JavaScript, but there is a Python SDK for LangChain as well. You connect to your model, so typically you pass in an API key, whatever you need. You can set things like the temperature, which can be important. So the temperature is going to determine how deterministic the LLM is going to be. LLMs are never deterministic, but with temperature you get a little bit of control on that. Similar for OpenAI. If I want to use OpenAI, I connect to the model in a similar way. I generate my prompt. So in here I can do all sorts of things. I should probably do some things like tell the LLM to don't concatenate answers or only provide full sentences, all these kind of things. And then the only other thing I really do is I take my prompt template and I send it off to the model. So here I'm connecting to the model. So that's the only thing you need in order to actually engage with a large language model via an SDK. There's nothing else needed, and all the other things you want to build on top of this is mostly to make the LLM context aware. So if you want to use RAG, retrieval augmented generation, You still have this code, but you write some additional code in order to connect to a vector database, retrieve the data, and all these kind of things. If you want to do agents and tool calling, you typically use a framework for this, but it's still very similar. So it's only like 30 lines of code needed in order to get started with sending a prompt to the large language model. So this is an example of zero-shot prompt. I have a prompt where I tell the LLM, I want you to do X, Y, or Z, and this is my question. We call this a zero-shot prompt because we're going to trust the LLM to give us a desirable answer based on basically no examples. So the LLM is going to use your question and the data has been trained on to answer this question. There are different patterns you can use for prompt engineering. One I personally really like is called few-shot prompting. So this is where you pass your question to the LLM, but you're also going to give some examples. So if you're asking about the best rated restaurants in a city, or maybe hotels you should go to, or touristic places to visit, it helps if you give the LLM examples, and then the format of the examples will be copied by the LLM as well. So it's going to use your examples, and we call this few-shot prompting because you give it a few examples of what you like to see. There's a website called the promptingguide.ai, and on this website you can find all the different prompting examples. So there's chain of thought, which is really useful for more complex questions. If you think about OpenAI's latest O1 model, it's doing chain of thought. It's not sharing the chain of thought with you, but it basically means that it's going to answer your question, it's going to validate if the answer would be good, it's going to revalidate before you actually get your question. So it isn't just simply answering your question, it's also reasoning and trying to find out if the answer is actually a good answer for your question. Then there's tree of thoughts. So this is where you give the LLM multiple scenarios. So if A, do B, or if B, do C. So tree of thoughts can be useful if you want to create a real long prompt and you want to take multiple answers as a possible option. So it's almost like a binary tree, but then with thoughts. Self-consistency and React prompting are important when you start to build agents. So a lot of agents you see today are doing React prompting. So I have a few slides on agents later on, but React prompting is what agents are using. So it basically means it's not going to act once, but it's going to act multiple times in order to provide you with an answer. So this prompting guide is really nice. They keep adding new examples. And one thing that's good to know when you start working with different prompts, it's always good to look at the model provider's website or the website of the model itself. Most models, they publish something called the model card. And on the model card, you can see how to structure your prompts. So chain of thought and tree of thoughts and React, those are sort of concepts of prompting. You actually need to go to the model provider itself in order to figure out the syntax for the prompt, because some of them have a very specific syntax for providing additional context, or for providing a question, or for providing variables in there. So I would always recommend to not just look at the patterns or the concepts, but also look at the actual model requirements itself. So whenever you do sort of LLM inferencing like I showed you, you probably want to do a bit more where you pass the LLM additional context. And you don't want this to be static, you want this to be dynamic, because maybe you're building an application and based on the answer or based on the question, the provided context should be dynamic, because every question is different, and you might have a large data set available that has bits and pieces that might not relate to all the different questions. So for this, we use a pattern called RAG, or Retrieval Augmented Generation. As I briefly mentioned in the beginning, there is a vector database involved. So if any of you have been working with search engines, then you probably have been using vector databases. If you build like a simple recommendation engine, you might have been using a vector database as well. So what happens before you actually create your prompt? There's a step involved where you search a vector database for related context. So in this example, maybe you're asking about, I don't know, the terms and conditions of a certain product, or you're asking about the cancellation policy for one of the agreements you might have signed with a provider or a vendor you work with. What it will do, it will turn your question into embeddings. It's going to look for related context in the vector database, and the vector database is then going to return matches of the vector database. So typically these would be chunks of data that match your question. There's a step involved where you load the data into the vector database. I'm going to show that in a bit. So your prompt will now not only contain your question, like what is the cancellation policy of my contract, it will also include the instructions that you set. So this might be helpful, be concise, and don't hallucinate, because models keep hallucinating no matter what you try. And it also includes the context. So this is relevant data coming from your vector database. So assuming you uploaded all the terms and conditions of products you're using in your company or personal life. So the LLM will now also see the relevant context, and then it's going to answer your question based on your question, the instructions, and also the provided context. Of course, the answer will only be as good as the data you provided with, because if you're asking about the cancellation policy, but you don't have the contract at hand, or you're maybe missing bits of data in there, then the answer is never going to be a good answer because it lacks data. So there's a step involved in the vector database where you're uploading data. Typically, this means that you take your data set and you're going to chunk it into smaller pieces of data. So chunking your data can have multiple strategies as well. You can do semantic chunking, so this is where you don't look at the chunk size only. So the chunk size it's not really a number of characters, it's more like a number of tokens. Or you can do semantic chunking where you actually take chunks that have the beginning and the end of a sentence and you don't concatenate somewhere in the middle. So there's something to be said for your chunk size as well. So do these chunks need to be big or small? That also depends on your data. So typically when you build a RAG pipeline, you do some testing to see if you need small chunks or large chunks and figure out what performs best. So you would chunk your data set, and there are libraries out there to help you with this. Because your data might be PDF files, it might be CSVs, it might be structured or unstructured, it might be code, it might be markdown, it could be anything. So typically you use libraries to do this. LangChain has some libraries built in. And then there's a startup which is called Unstructured, and they're pretty good in doing unstructured data. So they help you to go from unstructured data to chunks you can store in a vector database that you can then use to make the LLM context aware. So the vector database is really important when you do RAG. There's a number of vector databases out there. There are providers which offer cloud solutions, and there is a whole range of open source ones. I personally really like Chroma, which is an open source vector database. You can run it on your machine, you can self-host it, or they have some place where you can host it in their cloud as well. So loading data into vector databases can only be done after you chunk it. So RAG is really interesting. It's also a whole talk on its own because within RAG there's multiple patterns. You can do real-time RAG, you can do RAG on static data, you can enhance RAG with real-time data. There's multiple things you can do there. And you can also do this with less code by using some libraries that are available online. I actually have a LangChain example in here. It's still not that much code, so what I've done, I want to update stuff. Let me try and go to different branch, slash this. Yeah, so in this example, I have some data. I still have my generate answer function. Let me actually do this instead. I want to let me see what branches I have. Good. Check out solutions. Okay, this looks more like the code I was looking for. So within LangChain, there are a couple of things you can do in order to do RAG. As mentioned, you need an embedding model. So personally, I like to use TensorFlow for this because I can run it cheaply on my MacBook. Make sure to use the GPU version because the CPU is really slow. You need an embedding model in order to go from question to something you can match in your vector database. It's important to use the same embedding model when you store your data as when you retrieve it. Otherwise, you won't be getting any results. So first, you take your data. What I did, it's a really simple text file, but you can do much more. I'm splitting my data with a chunk size of 200, and then there's a little bit of overlap. And I'm storing all of this in a in-memory vector database. Then I have something called generate answer. In this case, it's using a tool, but it can also use my vector database, which I have somewhere in here. I maybe don't have the correct example. Let me use this one instead. Yeah, so this is a better example. So this is still the same code, so I'm generating and storing my data. I need to use an embedding model for it. When I generate my answer, I'm retrieving my data from the vector data store. And LangChain is going to do all the hard work for me. So it's going to retrieve the data, it's going to parse the retrieved data, and then it's providing the relevant context in your prompt. So still, this is like 80 lines of code in order to create a prompt. When you write a prompt and you're doing retrieval augmented generation, I always recommend to put in a prompt to only use the provided data, because sometimes it's still going to use its training data. So a previous conference, I was doing a talk about models, and I provided data about the elections, which you should never do, by the way. And it came up with the wrong name of the current president, the wrong name of current vice president, and it started to hallucinate all over the place. So if you ask questions about data that might overlap with training data of the LLM, be really precise in what you ask, and also make sure you put something in there so it doesn't hallucinate. Let me see if we can run this example. No, we can't. Oh, because I need to run npm install first. Let me see how fast that is. And then I need to use this legacy pure deps. So this example is using a bit of text. So I'm asking about things you can do in Amsterdam. There's also something in there about the number of bikes in Amsterdam. So this is a really specific question, which I'm pretty sure the LLM won't be trained on. So when I run the example, I actually want to try and ask how many bicycles there are in Amsterdam. And then it should use the provided context in order to answer this question. So it's still the same application. Now I'm going to ask how many bicycles are there in Amsterdam? And then I hope it won't say something went wrong, but you'll never know. So now it actually responds it's over 800,000. And I'm pretty sure it's this answer because, well, it's retrieving the relevant context. You can actually log some of the data. So we can try and see whatever is being used in here. So typically I recommend whenever you pass your answer to the front end or you're building some chat app, also show the user what data was being used, because then they know for sure whatever was going on there is correct. Back to my slides. I was somewhere here. So RAG is not the only way to make LLMs context aware. I mentioned in the beginning there's also something called tool calling and agents. And also something which might be interesting is a large context window. So if you read a bit about the latest models, you saw some of them have really large context windows of like hundreds of thousands of tokens. So this means that, for example, with the latest model from Meta, so Llama 3.2, you can actually provide the entire Harry Potter, the second Harry Potter book as context. So you could provide the entire book's context, put it in a prompt, and ask the LLM questions about this context. Something to keep in mind is it's going to be really expensive because, as I mentioned, you pay per token. So if the Harry Potter book is like 300,000 tokens, you're going to pay for those 300,000 tokens. It still shouldn't be that expensive. Typically, 1 million tokens is like $5 or $6. So it shouldn't be too expensive, but if you ask repeat questions, it's going to keep looking at the same tokens, and over you're paying for those tokens. There are some things you can do like caching, but still RAG would be a better solution for this because you're dynamically picking the pieces you need and thereby reducing the number of tokens sent to the LLM. You can also train or fine-tune your model. So let's assume you want to make sure the model provides better answers. Training or fine-tuning can be good, not necessarily to make the LLM smarter, but more or less to make the LLM more fine-tuned towards your tone of voice or fine-tuned towards the way you do things. So fine-tuning I see a lot with companies that are using large language models to generate documents or presentations or contracts because you want to fine-tune the model on your tone of voice, on your way of structuring documents, on your way of structuring any sort of template that you want the LLM to generate. If you don't do this, if you don't train or fine-tune, you can still use the prompt to make the LLM create better solutions based on your tone of voice. But then the token count will be higher because you need to provide examples. So you can do few-shot prompting, for example. So the final bit I wanted to share is AI agents. So this is really where everything is moving. 2 years ago, we saw ChatGPT, we learned about large language models. Then I think a year ago, everyone was doing RAG. If you think what people are doing today, they're building agents. So there are agents to do all sorts of things today. There are agents to help you build your website. There are agents to help you book your travel if you wanted to. And companies are starting to provide agents to their customers as well. So I should have included it in here, but there was a tweet from someone working at Stripe that Stripe is now providing agents to developers building on the Stripe platform. So instead of you creating code on top of the Stripe APIs, you actually connect to a Stripe agent, and the agent will make sure the correct APIs are being called, the IDs that are needed are being pulled from the system. So I see it's going to a place where companies are developing agents rather than APIs, and those agents are doing the hard work for you, reducing the amount of code you need to write when you integrate with some developer platform. So agents still have the same pattern. You can have an agent in the chat interface, you can have an agent running somewhere as an API, but you still have a question and you want that question to be answered. So in the middle, there is still code involved, there is still something happening. And for agents, typically we're using a plan like this. There's multiple ways to do agents. One of the more popular ways is this one. So this is where you have your question. You're going to send your question in a prompt to the large language model. Well, actually, you're going to send it to the agent, but you can use models as agents nowadays. So you take your prompt, you send your prompt to the agent. The agent is going to look at your prompt. It's going to look at the available tools it has. For example, can it retrieve data from an invoice system? Can it retrieve something from a vector database? Can it call external APIs? Based on the available tools, it's going to create a plan for your question, because maybe your plan involves multiple tool calls or multiple external systems that need to be crawled. Then the agent is going to act for you, so you don't need to execute any of these tool calls yourself. The agent is doing it. So think about the agent as an autonomous system that you give a task, and it's going to perform the task, and the only thing you really control is the tools you give the agent. And then finally, it's going to send all the information it retrieved from the different tools to the LLM, and then the LLM is going to generate your final answer. So what some agents do, they also reflect. So they're going to look at whatever it did. It's going to validate if whatever it did is good enough. Then it's either going to restart the loop, or it's keeping track of it somewhere, so the next time you ask this question, it's going to have to do less tool calls. Because maybe some of the tool calls fail, maybe some of the tool calls aren't providing the answer you need, or they're poorly structured. There's a whole range of things you can do on the tool calling side. And there's a whole range of things you can do on the agent side. So there are a lot of open source libraries to help you build agents. There also are open source libraries to help you build tools. So my opinion, if you look on the left side isn't as developed as the right side, because the right side is just APIs and databases. And as developers, we've been doing APIs and databases for many years now. So think of the tools as sort of a given or a well-developed and already maturing part of agents. The way an agent generates your answer is something that changes every day. Every day people publish papers on better ways to do agents, on better ways to do planning, better ways to do reflecting, on better ways to create multi-agents or single-agent systems. So let me show you an example for this. First, I have an example of like really simple tool calling. So now I'm going back to my previous branch, which is actually a better one. Go to stash and then check out this, and then let me run npm install again. Close. So let's look at pure tool calling first. I don't need this. I do need the tool definition. So if you want to do tool calling, you would define the tools that are available. And to define the tools that are available, you can use either tools from LangChain, you can use tools provided from the internet, or you can create your own tools. If you create your own tools, you typically use the runtime of the programming language you use to build these apps. So this is JavaScript, so I can build JavaScript tools, which can be a JavaScript function that does whatever. It could be calling an API, it could be querying a database, it could be using JavaScript built-in functions to do some basic math. It can be anything. In here, I'm using a LangChain tool, which is the Wikipedia tool. So this is already built for me. The only thing I do, I wrap it in a function so I can execute it. Then I'm using Llama 3.2 from watsonx in order to take my question and my tools and then provide an answer. So my tool definition will look like this. I have a Wikipedia tool. I have a tool description. And the tool description is really important. The tool description is almost like a prompt on its own, because it's going to tell the LLM how it can use this tool and what information it can retrieve. Assuming you might have 10 tools or 100 tools, it gets really important to write good tool definitions. So tool definitions involve a bit of prompt engineering as well. You can also provide examples on how to use the tool. Typically, I'd say try to create tools that are easy to use, because it will make the LLM act faster, or the agent act faster. And then you need to define what parameters are available. So in here, I have a prompt template. There's some things in there which I feel are needed, like make sure the LLM should not include any other text in the response, make sure it's going to provide no answer in case it won't be able to use the tools. So I don't want the LLM to hallucinate. And then there is some text in here to actually call the tool. So what I do, I first send my tool definitions and my prompt to the large language model. It's going to create an answer, and the answer actually includes a tool call. Then I wrote some code to actually call the tool, and then I'm going to provide the tool response back to the LLM. So it's a small agent I built by hand. I'm not using an agent framework, but this should be able to help me answer questions. So when I run this application, I can go back to my browser here. I'm using a Wikipedia tool, so I can probably ask things that should be on Wikipedia. So maybe we can ask, what is the population of Atlanta? Let me open the console to see what it did. It was really fast, so it's probably taking something from training data. But I am logging the tool calls somewhere. No, so it's not taking any of the data from my tool. It should be doing this, because somehow it's not using the Wikipedia tool. So maybe I didn't formulate my prompt correctly, could be. Or maybe I should ask a more complicated question. So what are the biggest neighborhoods So now it's giving me an answer, which could be coming from training data, it could be coming from the tool calls where it's using Wikipedia. So I should probably log some things in the middle here to make sure it is calling my tools. I probably want to do something in here, console.log. I probably want to do it down there. Results. I could use Langsmith for tracing, yeah. Yeah, it's really useful for tracing indeed. So let me try again. So what are the biggest neighborhoods in Atlanta? And then we probably get a similar answer, but now let's see if it's been using my tools. Well, it hasn't, but before I'm going to debug with all of you here, I have all of this in a repo, which is this repo here. So you can actually simulate this yourself and see if you're smarter than me, and you can make it work. So in here you can find like step-by-step examples on how to do this. So it sort of takes you through the journey of doing LLM inferencing and some basic prompt engineering to retrieval augmented generation on a local data set, and then finally tool calling where you build your own agent. So make sure if you look at it today to actually fork it, because I might make some changes every now and then, so you might lose it if you want to follow this this repo. So agents, what I showed you was a really simple agent. It wasn't working for some reason. I'm going to figure out why later. But what we saw, it's using a tool, which was the Wikipedia tool. You can also take in your own APIs, your own microservices, or whatever you might be using. And then the LLM should create a plan based on your tools, execute those tools via the agent, and then finally give you an answer. So in the near future, I think everything we'll be doing is involving around building agents that you publish to external users, or agents that you build internally. That doesn't really matter. So I have some links here which you can use. So as mentioned, I work at IBM. We have a developer page where you can find examples. My AI workshop is here. So I've been running this workshop for a while, and you learn how to build the things I just showed you. And then there is a free course on getting started with AI, which we build at IBM. So you can take it for free, and it's going to show you some of the concepts of using LangChain with either JavaScript or Python, or how to do prompt engineering, and all those cool things. So long story short, building AI applications is just like building any application today. There are APIs and SDKs to help you get started. You still need to write front-end code or integration code, and you can use LangChain, for example, to make things go faster and skip some steps. I do feel it's a fast-moving space, so you can find a lot of different libraries and frameworks. They might be changing every day. And you figure out working with LLMs is kind of hard because they're not really trustworthy. Sometimes they're going to give you one answer and then the next time another. Like I said, in a previous conference, I tried to ask who the current president was of the US, and it didn't do well. It used the vice president's name or a former president, or it came up with like unexisting names. So don't trust LLMs, but do trust the tools you build on it, and make sure to guide the LLM through using your tools rather than coming up with data that's been trained on. I also have a Discord channel where you can join and ask questions if you want to stay in touch, or you can find me on social media. So thank you.